All right, guys, welcome back. We're going to get into 1.4 today. Hopefully these videos have been good for you guys, and hopefully you've been able to move at your own pace and see which parts you do like about these, see some things that you don't like about this. And then always feel free to tell me if there's anything I can be doing differently in these videos, anything that I need to clarify. Always feel free to let me know that either in the Zoom chat or through email or whatever that might look like. Okay. For today, we're getting into one of our last sections for Unit 1. We've talked a good amount about segments, and then we kind of introduced the idea of angles and different types of angles on, it would have been Wednesday or Thursday. And now today we're getting into specific angle relationships. Okay, so that will be the title for today. Date today is either Friday the 18th or Monday the 21st, depending on what day you're having this. And then objective for today, want to be able to use these angle relationships to solve for measures of angles and variables. Okay, this is the first time that we are, or one of the first times I should say, that we're getting into these ideas with geometry where we have information about a pair of angles or this group of angles, and then we can use that to solve different problems. We do that all the time in geometry, and so we're going to kind of be practicing that a good amount today. Okay, so first thing here, I'll move myself up. Okay, first definition we're going to write down are adjacent angles. Okay, adjacent angles, if you can think of, or if you understand what that word adjacent means, it pretty much just goes along with that. Adjacent angles are two or more angles that are next to each other. Okay, very helpful to know what this word adjacent means and to know what how that applies to adjacent angles. But again, this is just adjacent just means two things that are next to each other, two or more things that are next to each other. In this case, that's just two or more angles that are next to each other. Okay, we don't use that for specific problems, but it helps to understand that definition because then we get into a linear pair, and that helps us kind of define that a little bit better. Okay, so a linear pair, we're going to use the technical term first, and then I'll draw a diagram of it. Okay, a linear pair is, as it sounds, a pair of angles, or two angles, a pair of angles that are adjacent, two angles that are next to each other, two angles that are adjacent, and whose non-common sides are opposite rays. Whose non-common sides are opposite rays. Okay, so like I said, this is a very technical geometry definition, right? It doesn't make too much sense right now. Okay, if we draw an example of this, here's what I'm going to do is I'm going to have, just starting off, I'm just going to draw a straight line. Okay, and then if I'm looking for what a linear pair looks like, a linear pair always happens, linear meaning a line, is just when I take a line and I basically break it up into a pair of angles or two angles. So I can draw a line, or I'm sorry, a ray going out from any of these positions at any angle. So we'll just draw this one here, it doesn't really matter. And let's just label this angle 1 and angle 2. Okay, this would be an example of a linear pair. Two angles that are right next to each other, right? You have angle 1, try to use a different color here, angle 1 right next to angle 2, and their non-common sides, so the ones that are not touching or not adjacent, are opposite rays, so rays that are going directly in opposite directions. Or in other words, these two angles form one straight line. Okay, and that helps us because we can use that to solve different problems for different angle measures. And you'll see that that phrase come up a good amount, linear pair. Okay, so notice here one other thing I just want to mention. Okay, if I see a diagram like this, you don't need to draw this. If I saw this would not be considered a linear pair. Like if I asked if I had two angles right here, 1 and 3 would not be considered a linear pair because there's another one in between them. Okay, it has to be two angles, and it has to be the only two angles on that straight line. In that other case, there would be 3. Okay, and then this last one here, extremely important. We use this a lot in geometry, so you want to make sure you understand what this definition means. Okay, vertical angles are, and I'll write this down here, a pair of angles, or let me get more technical, a pair of non-adjacent angles, that are formed by two intersecting lines. Okay, a pair of non-adjacent angles that are formed by two intersecting lines. Okay, so again, that's really geometry vocabulary heavy. Okay, if I look at this example here, all I need is two intersecting lines. So I'm going to draw this out to the side here. Two intersecting lines. And if I look at this, if I name just these going around the sides of these two intersecting lines, we have 1, 2, 3, and 4. Okay. Why is this important? Why does this help us, or how do I define this first? Let's start with that. If I look at just, for instance, angle 1, and I'm trying to find the angle that is vertical to it, or the vertical angles, okay, the pair of vertical angles, I want something that is non-adjacent, so it's not right next to it. Okay, so that rules out 2 because 2 and 1 are right next to each other. They have that common side, and then same thing with 1 and 4. So the only other one that would be a vertical angle with 1 is 3. They're kind of opposite of each other. They're not adjacent. Okay, same thing goes for angle 2 and angle 4. Those would also be vertical angles. Okay, it doesn't have to mean vertical. It's like it just has to be up and down. It's just the geometry term that we use for non-adjacent. Okay, and why is this important? One more little piece right here I'll put underneath, and you can put this as well, is vertical angles are always congruent. And I'll write it out. You could use the congruent symbol as well if you'd like to. Okay, I'm going to put a box around that because that is important. We want that to stand out. Why do we care if two angles are vertical angles? Because they are always congruent. And again, they're always formed anytime I see two intersecting lines. So we're going to see a lot of examples of this in geometry. When anywhere we have two intersecting lines, you need to see, all right, those are vertical angles, number 1. And then number 2, I know they're congruent. Okay, because that helps us solve for angle measures a lot faster. If I have 1, I have both of them, right? Okay, so let's use that here to try to solve some of these problems. Okay, I'm going to scroll down, move myself out of the way. Example 1 here. I want you to take a sec. As always, I want you to sketch this diagram. Make sure you include all the points and make sure you include all the lines. Okay, I'll give you a sec to do all that. And pause your video. Okay, so we're looking at example 1. We have this whole diagram. We have all these points. First thing it wants us to do is it wants us to name a pair of vertical angles. So if I want to figure those out, again, if we look back at that definition, it said those are formed whenever I have two intersecting lines. And remember, not rays. Rays are just an endpoint going off in a direction, but I want a line. I want some kind of segment that is going off infinitely in both directions. Okay, so if I look at this diagram, what I see here is I have two lines that are going off infinitely. I have line, we can name this JM, because that's 2 points on the line, right? Name this here. And then we have line segment PL. Okay, remember I don't have to name them that way, I'm just doing that for the example of this problem here. Okay? So if I'm looking at these two lines, I know that when they intersect, they're going to form vertical angles. So now I'm looking for a pair of angles that are not next to each other, but are basically opposite of each other. Well, the easiest ones that I see to work with here are this angle right here and this angle right here. Okay, they're opposite of each other. Okay, I could do the other two over here as well, but this one kind of gets a little bit more messy. So I'm just going to use the first ones that I marked. Okay, so I have these angles here, and now I need to remember how to name them. Okay, so we think back to last lesson. We say, okay, I need the 3 points that make up that angle, and I need the vertex, or the common endpoint, to be in the middle. So if I look at this first one here, I start at J, and it goes J, N, P. So I'm going to say angle, make sure we have that symbol there, and then JNP. Okay, again, vertex in the middle. So I'm going to say that's one of the two, right? It's a pair, so it's two. And then angle, if I'm looking at the other one, there's a couple different ways to name this. We'll just say angle MNL. Starting at M, N is my vertex, and then going out to L. Okay, that would be my pair of vertical angles. Remember, if it's asking for angles, I'm not going to write the line JM or the line PL. Okay, I'm always thinking angles. I'm always thinking 3 points with that angle symbol. Okay? So, with that being said, if I'm looking at this, now part B, it says, excuse me, if I'm given that measure of angle JNP equals 60 degrees, it wants me to find the measure of angle LNM, and it wants me to find the measure, remember that little M is just saying measure, of angle MNP. Okay, so first thing I'm going to do, anytime I'm given information, once I figure out, okay, that's the length of a segment, or that's the measure of an angle, I'm always going to mark that on my diagram. So I have this here, JNP is 60 degrees. So let's start with the first one. If I'm looking at LNM, okay, again, I'll draw that out just in case we didn't catch that one. LNM here. Or just like we named it, we just named it MNL, exact same angle. Okay, as long as it's got the 3 points, as long as it's got the same vertex. And it's asking what is the measure of angle LNM. Well, we just said this. We know these are vertical angles. We scroll back up, we know vertical angles are always congruent. So if measure of angle JNP is 60 degrees, then the measure of angle LNM is also 60 degrees as well. Okay? And one thing you'll notice as well on diagrams, we talked about this with line segments. Anytime I want to show that two line segments are congruent, I put a little dash mark. Anytime, and you'll notice I did this on this diagram with the angles, anytime I have two angles that are congruent, I'll always put the same amount of arcs on them. So on JNP here, I put 1 arc, and then same thing with L and M. I knew that they were congruent, so I put the same amount of arcs on them. Okay, and then the same would go if I put 2 arcs, and 2 arcs, 3 arcs, and 3 arcs, so on and so forth. Okay, so we have this one here, and now I'm going to write that in just so I have that information, 60 degrees. And then the next part here is it's asking for the measure of angle MNP. So I'm going to try to label that with a different color so we can see that. And I'm sorry, some of my ink has kind of gone over some of the points here, but if I start at M, go to N, and then P is actually out here, this whole angle right here, I'm going to mark it with 2 arcs, so I know that I'm not talking about, it's not congruent to the other two. We notice it's much bigger, right? And if we're thinking about what we talked about on Wednesday or Thursday, we said that this is going to be an obtuse angle, because we notice it's much bigger than just 90 degrees, okay? So the way to figure this out is thinking back to what we talked about with our types of angles last time. Last time we said, anytime I see a straight line, excuse me, anytime I see a straight line, that measure angle, or the angle of that, the measure of that angle, excuse me, is always going to be 180 degrees. Well, if I look right here, we already said we have this line JM. Write this again, JM, this line right here. Okay, and if I want to simplify this, I'm just going to write this, I'm just going to draw this line out to the side a little bit. Okay, I have J, I have M down here, I have N kind of in the middle, and I'm just going to draw the left side of this picture so I can visualize it a little bit better. Okay, we have P, we have 60 degrees, right? And we said if I have a straight line, that straight line JM right here, I know that the angle measure of this whole thing is always going to be the same thing. It's always halfway through a circle, so it's always 180 degrees. So if I'm thinking back to what we talked about with kind of segment addition, the same thing works for angle addition as well. If this piece is 60 degrees, and I know the rest of it has to add up to 180, all I need to do to figure this out is I need to say the measure of angle MNP equals the whole thing, 180, minus this little piece here, okay, which in that case is going to be 60 degrees. Okay, notice this missing part right here is going to be 180, the whole thing, minus 60, which in this case is 120 degrees. Okay, so that's something that we can kind of notice with some of these pictures is anytime I see a straight line, the whole thing is going to be 180. So if I want to find little pieces in there, I just need to figure out what are the other angle measures that I know, and then just take those out. Okay, and then last one here, putting our skills to the test a little bit more. Suppose angle J in K, so we'll draw that here, J in K. Okay, so I'm looking at this one up top here. It says it's twice the size of K in L. Okay, so let's look at this here. K in L. It says it's twice the size of it. Okay, so if I'm trying to figure out what that is, one thing I can do, number one, is I can fill in the information we just found from last time. That is 120. Okay. Another thing I can do here is if I'm going to set up an equation for this, I have to think algebraically. So we have two unknown numbers here. Let's start with K in L. We know K in L, this little angle right over here, okay, is just some measure, right? So if I have some unknown number and some unknown measure, the way we usually represent that in algebra is just x. Okay? So let's say measure of angle K in L is going to equal x. We're just applying that. Okay? And then we said J in K, the other one up here, is going to be twice that measure. So angle J in K equals, well, if I have x and I want twice the size of that, if I want to put that in terms of algebra or algebraically, I can just say that is 2x. Okay? So we have x here, we have 2x, and now we need to figure out how to set up an equation to solve for x. Well, if I think about these two on their own, if I just had that information, I couldn't solve because I could just plug in a bunch of different numbers. But I notice here, again, I'm going to use vertical angles. I see the two purple arcs that I drew over here. That is going to be a vertical angle with the big angle J in L, excuse me. I've drawn over so many of these parts here. The whole big angle J in L that looks like this, if I raise my arms up a little bit, is going to be vertical angles with the one we just found. So if this whole thing is 120, then so is this whole thing 120. So I know these two angles that are next to each other, they're going to add up to 120. Okay? So if I know that, then I can just set up an equation. I can say this part right here, which we just said is x, plus this other part right here, which we just said is 2x. If I add those together, it should give me the measure of the entire angle, which we already know is going to be 120. Okay, if that's not making sense, feel free to hop in the Zoom call and let me know, and I can kind of go a little bit more in depth with that. Okay, but now that we have our equation, it's fairly simple. We just want to solve for x. So we know x plus 2x, that's just going to give me 3x, and that equals 120. Remember, we're just combining like terms here, 1x plus 2x. And then last step to solve for x, we cancel out, we divide by 3, we get 120 divided by 3, which is 40 here. Okay, and I'm going to put a box around that. Okay, and remember, anytime we have to find a variable, we always want to check, is that what the question was asking for? I look back and it says, well, I want to find the measure of each. So what I'm going to do, first of all, I know measure of angle K in L is just x, so we just found that. That's just 40 degrees. So I have found one of my answers. I can just plug that back in, right? Okay, on angle J in K, we know it's just going to be twice the size of that, or it's just going to be 2 times that. So in this case, all I need to do is just take 40 and then multiply by 2. And that's going to give me 80 degrees. Okay, again, if any of that's not making sense, feel free to ask and I'll be happy to kind of explain that. Sometimes it's a little bit easier to explain these kinds of things one-on-one, okay? And I know I understand that I drew a lot on that diagram there, okay? So we have this here. Now trying to use this for other parts as well. Other things that we're going to need to use, and this will go a little bit quicker hopefully. Couple definitions, that we need to know. First one is going to be complementary angles. Complementary angles. All right. Anytime I see that, or what that means is complementary angles are just 2 or more angles that add up to 90 degrees. Okay, complementary angles are just 2 or more angles that add up to 90 degrees. All right, if I want an example with that, I could draw this here. Let's draw a 90-degree angle. Okay, 2 things with this. Number 1, remember, we have a name for this that's called a right angle. Okay, and then number 2, if we do want to show that it is 90 degrees or that it is a right angle, we always put this box in the middle. Okay, or I'm sorry, not in the middle, but on that corner, on that vertex. Okay, and then if I want to show 2 angles here that add up to 90, I can just draw a ray going out. to create these two angles, angle 1, this little slice, and then angle 2, the big slice. We know each of these pieces make up the right angle. We know the whole thing is 90, which means each piece added together is going to give me the whole thing. Just kind of like what we talked about with segment addition. Just applies to angles. Okay? And then last part here, the other last definition we're going to talk about is supplementary angles. Very similar. You might be able to guess the definition for this. Supplementary angles are two or more angles that add up to, in this case, or in this time, 180 degrees. Okay, supplementary angles are just two or more angles that add up to 180 degrees. Okay, so an example of this, if I want to think again, if I want to create a picture of an angle that I know the total is 180, we know the best way to do that is just to draw a line. So we draw a line here. I can have a ray coming out from any direction, doesn't really matter. We'll name these ones 3 and 4 just so it's a little bit easier. Now I would say 3 and 4 are two things. Number one, we've already talked about this, right? They're called a linear pair. Two angles that are on the same line right next to each other. Okay? So that'd be a linear pair, and then also, I know since the whole thing is 180, they're going to have to add up to 180. So if I was writing an equation for that, I could write this out to the side. Angle 3 plus angle 4 equals 180. And then same thing for the complementary angles. I could say angle 1 plus angle 2 equals, in that case, 90. Okay? So that's the idea. That's how we use these to set up equations. Okay? All right, so let's try to get through these last couple here. Give you some time to work on your assignment. All right, if I'm looking at this one, it says, given the figure, I want to find the measure of angle WTR if angle STW and angle WTR are complementary. So again, take a second, sketch this diagram for me, pause your video, and then we'll come back together. Okay? So hopefully you got the time to do that. If I'm looking at this picture here, I said I want to find the measure of angle WTR. I know that means I have to find what X is. So I look at these here, STW and WTR. It tells me these two angles, I'll use a different color for WTR. These two angles are complementary. So if I want to set up an equation with that, we just use what we talked about. That means that it says, or if we can say, angle STW plus angle WTR is going to equal what? 90, right? Because we just said they add up, complementary angles add up to 90. And now all I need to do is plug in what I know for these angles. So I know a measure of angle STW. I look at the picture, I see that's 2x right here, or 2x degrees. Okay, plus measure of angle WTR, we're told right there that is 5x plus 6. And we know the whole thing equals 90. Okay? This is how you want to get in the habit of setting up these equations. What information do I know? What are the names of them? And then just plug in your variables. And then from here, it's just using your algebra skills. Okay, so I see x is on the same side of the equation. I can combine 2x and 5x to be 7x. And then plus 6 equals 90. Next step here, subtract 6. I get 7x equals 90 minus 6 is just 84. And then last step here, divide by 7, and I'm going to get x equals 12. Okay, that's what I find for x. Again, it's not asking that, it's asking for the measure of angle WTR. So I would go ahead and plug that back in, and I'll just tell you this for the sake of time. Measure of angle WTR, once you plug that back in, would be 66 degrees. Okay, and you can check that, and you can plug back in for the other angle as well and ensure that they do add up to 90, which in this case they do. But like I said, we're on a little bit of a time crunch. This video is going pretty long, so don't want to have you spend too much time on that. Okay, so x equals 12, and then do need to write that final answer. WTR equals 66. Okay, last one here. One last diagram for you to draw real quick. Give you a sec, pause the video. You don't need to label any points, just need to label the lines and the angle measures. Okay, so with this, I'm looking at this and I say I want to determine the types of angles given, first of all, which I always want to do, and I want to use that to solve for the value of x. Okay, so I see I have these two angles here. I don't have names for them, but I am given what they are, or the measures of them algebraically. So if I see these two angles here, we have a couple different names for these. Okay, it does want me to determine the types of angles, so I'm going to write this down. This is either a linear pair slash these are supplementary. These are supplementary angles. Because like we've said before, if I look at this diagram here, I see this line, this straight line, going off in both directions, and I see I have two angles that are right next to each other that form that straight line. Well, we know the whole thing is always going to be 180, so they have to add up to 180. Okay, so with that being said, we're just going to set up an equation that shows exactly that. So I have 2x plus 9 as one of my angles, plus 4x plus 3, the other angle, is going to equal the whole thing, which we know the measure of any straight line is 180. This is the biggest piece. If you understand this piece, then the rest is just solving. The part plus the part adds up to the whole thing. Okay, and now from here, we can just use algebra. We can combine like terms first. We have 2x and 4x to give me 6x. 9 plus 3 is going to give me 12. Equals 180 here. Scroll down a little bit. Next step, subtract 12 from both sides. When I do that, these cancel, leaving me with 6x equals 168. All right, and then last piece here, if I divide by 6, I should get x equals, and then I could either type this into my calculator or try to figure it out in my head. Either way, your answer should come out to be 28. Okay, final answer should be x equals 28 there. 20 and then 8, yep. Okay, so I don't need to plug anything back in because it was not asking for a measure of any angle. Okay, so like I said, this video has gone on a little too long, or a little long, but wanted to cover all that. Assignment for today is going to be 1.4 homework, angle relationships, so kind of practicing these ideas as well. Could I apply this to some of the problems that we are going to be working on, solving for a variable and solving for measures? Okay, so I'll direct you guys in the Zoom call when you guys can go ahead and start working on that, or whether we're going to do an activity. All right, but that is the notes for today. If you have any questions, always feel free to ask. Thanks, guys.